Right now, as you watch this, a space telescope a million miles from Earth is quietly pointing at a distant star, waiting for a shadow. Not a big dramatic event. Just a tiny, tiny dip in the starlight, a flicker so faint that if you saw it with your own eyes, you would never notice it. And yet that flicker is one of the most important things a human being has ever measured. Because inside those flickers, over the last 15 years, we have found thousands of other worlds. Some are hellish, some are frozen. But a handful, a precious, unsettling handful, look disturbingly like home. Worlds with the right size, orbiting at the right distance, where liquid water could pool on the surface and an ocean could sit under the sky. One of them was so similar that NASA itself, in an official press conference, called it Earth 2.0. And here's the part almost nobody outside of astronomy has fully absorbed. We may have already photographed the atmosphere of a world where something is alive. Not confirmed, not proven, but close enough to make serious scientists lose sleep. So let me walk you through exactly what we've actually found and where the honest line between discovery and hype really sits. Before we go any further, if you want the real version of this story, the version with the actual data and the actual caveats instead of the usual breathless nonsense, consider subscribing. That's the whole point of this channel. Real missions, real researchers, real numbers. When something is confirmed, I'll tell you it's confirmed. When it's just a tantalizing maybe, I'll tell you that too. No exaggeration, no invented aliens. Just the genuine, jaw-dropping truth of what's out there. Okay, let's begin. To understand how we got here, we have to go back to a man who spent almost 20 years being told no. His name is William Borucki, a scientist at NASA's Ames Research Center in California. And for 2 decades, Borucki had a stubborn, almost lonely idea. He believed that if you stared at a patch of sky long enough and watched thousands of stars at once with incredible precision, you would catch planets crossing in front of them. The problem was, almost nobody thought it would work. The dips in light he wanted to detect were absurdly small, like trying to notice a single moth flying across a distant stadium floodlight. His proposals were rejected, again and again. Colleagues doubted the technology could ever be sensitive enough, but Borucki kept refining it, kept pushing, kept arguing. And finally, in March of 2009, his idea launched into space aboard a spacecraft called Kepler, a modest telescope with a single, obsessive job: to watch one small region of the sky, around 150,000 stars at once, in the direction of the constellations Cygnus and Lyra, and wait for shadows. The precision required was staggering. Kepler had to hold its gaze so steady and measure brightness so exactly that it could catch a star dimming by a fraction of a percent and not blink. For 4 years, it just stared. It didn't move on. It didn't get bored. It watched the same stars, patiently, hour after hour, logging every tiny flicker. And slowly, the candidates started rolling in. Dozens, then hundreds, then thousands. What came back changed our understanding of the universe permanently. Here's what most people believed before Kepler, and honestly, what a lot of scientists quietly assumed too. Earth was special, a lucky accident. The thinking went something like this. Sure, other stars probably have planets, but a world like ours, the right size, the right distance, liquid water, stable orbit, that had to be rare. Maybe vanishingly rare. Maybe we were close to alone. For most of human history, we had exactly one example of a life-bearing planet, this one. And when you only have one of something, it's natural to assume it's a miracle. In fact, go back just a little over 30 years to before 1995, and here's a fact that stuns most people. We didn't have solid proof of a single planet orbiting a single other sun-like star. Not one. For all we knew, our solar system might have been a freak of nature. That assumption did not survive contact with real data, because when Kepler started sending back its results, the sky turned out to be absolutely crowded with planets. Not a few, not hundreds. Thousands upon thousands, hiding in plain sight around almost every star Kepler looked at. Rocky ones, gas giants, scorched ones, frozen ones, worlds bigger than Jupiter and worlds smaller than Earth. Planets turned out to be the rule, not the exception. Today, we've confirmed well over 5,000 of them. And that was only the beginning of the shock. So how do you actually find a planet trillions of miles away that gives off no light of its own? You don't see the planet. You watch the star. This is called the transit method, and the idea is beautifully simple. When a planet passes directly between its star and your telescope, it blocks a tiny sliver of that star's light, and the star dims, just slightly, before brightening again. Picture a moth crawling across a light bulb. The bulb doesn't go dark, but for a moment it's a hair less bright. Measure that dip precisely enough, and it tells you the planet exists, how big it is, and how long its year lasts. And these dips are almost nothing. When Earth passes in front of the Sun, seen from far away, it blocks about 1/100th of 1% of the light, like spotting a flea crawling across the beam of a car headlight from miles away. That's the level of precision we're talking about. Kepler did this for thousands of stars simultaneously, and it turned a trickle of known planets into a flood. Then, in 2018, a newer NASA telescope called TESS took over, scanning almost the entire sky instead of one patch, hunting for the nearest and brightest stars with transiting planets, the ones close enough to study in detail. But finding a planet is only half the story. The real magic came with the next instrument, the James Webb Space Telescope, launched in December 2021, the largest and most powerful telescope ever sent to space. Webb can do something that, even 20 years ago, sounded impossible. When a planet transits its star, a thin ring of starlight filters through that planet's atmosphere on its way to us. And different gases absorb different specific colors of light, like chemical barcodes. So by splitting that filtered starlight into a spectrum, like a prism spreading sunlight into a rainbow, Webb can read the chemical fingerprint of an alien atmosphere from light years away, molecule by molecule. Let that sink in. We can now sample the air of a world we will never visit. And that is where this story stops being about dots on a chart and starts becoming something far stranger. Let me take you through the discoveries, one layer at a time. The first major milestone came on July 23, 2015. NASA called a press conference, and the announcement was extraordinary. Kepler had found a planet called Kepler 452b, orbiting a star about 1,400 light-years away in the constellation Cygnus. And this one was different from the thousands before it. Its star, Kepler 452, is what astronomers call a G-type star, the same class as our Sun. Nearly the same temperature, nearly the same brightness. And Kepler 452b orbits it once every 385 days, just 5% longer than our own year. Sit with that for a second. A planet, circling a sun-like star at almost exactly Earth's distance, with almost exactly Earth's year. John Jenkins, the Kepler data analysis lead at NASA's Ames Research Center, who led the discovery, described it as an older, bigger cousin to Earth. He said if you stood on its surface, the sunshine would feel a lot like home. The press ran with two words that stuck: Earth 2.0. Now here's the honest part, because it matters. Kepler 452b is about 60% larger across than Earth, a so-called super-Earth, and we still don't know for certain what it's made of, whether it holds water or whether it can host life. Later analysis even raised questions about how solidly the detection holds up at that enormous distance. But as an idea, it was a turning point. The confirmation of Kepler 452b pushed the total count of confirmed planets past 1,000 at the time, but more than any number, it did something to people. It made the abstract feel personal. For the first time, we had found a world that genuinely resembled our own, orbiting a star genuinely like our Sun. The dream of another Earth was no longer science fiction. It had coordinates. But none of that prepared anyone for what came next. A second discovery, announced in the journal Nature in February 2017, arrived from a modest telescope in Chile with a wonderful name, TRAPPIST. Led by astronomer Michael Gillon of the University of Liège in Belgium, a team had been watching a small, dim, cool red star only about 40 light-years away. 40. In cosmic terms, that's practically our backyard. And around that single tiny star, they found not one planet, not two, but 7. 7 roughly Earth-sized worlds, packed tightly together, all orbiting closer to their star than Mercury orbits our Sun. And several of them sit in the habitable zone, the narrow band around a star where the temperature could allow liquid water to exist on the surface. Not too hot, not too cold. Think of it like sitting the right distance from a campfire. Any closer and you burn, any farther and you freeze. 7 Earth-sized planets around one star, several possibly capable of holding oceans. It was, and still is, one of the most extraordinary planetary systems we've ever found. The team confirmed the full count using NASA's Spitzer Space Telescope, which watched the star almost continuously to untangle all 7 orbits. And here's a detail that gives me chills. Those planets are packed so tightly together that if you stood on the surface of one, the neighboring worlds wouldn't be faint dots, they would loom in the sky, some appearing larger than our moon does from Earth, close enough to see clouds and continents. a sky full of other Earths hanging right there. There's also a reason red dwarf stars matter so much in this search. They are the most common stars in the galaxy, and they burn slowly, living for tens or even hundreds of billions of years. That's an almost unimaginable stretch of stable time for life to potentially get started. If you're finding this as fascinating as I did while putting it together, do me a quick favor and hit like. It genuinely helps this kind of grounded space content reach more curious people instead of getting buried. The third discovery brings the search almost uncomfortably close to home. In August 2016, astronomer Gillon Anglada-Escudé and his team announced, again in Nature, that they had found a planet orbiting Proxima Centauri. And Proxima Centauri isn't just any star. It is the closest star to our Sun, a small red dwarf just 4.24 light-years away. There is nothing nearer. The planet, called Proxima b, is at least as massive as Earth, and it orbits within its star's habitable zone, where liquid water is at least possible. And it was found in a completely different way from the others, not by watching for a shadow, but by watching the star wobble. Here's the idea. A planet's gravity tugs on its star, pulling it in a tiny circle, and that motion stretches and squeezes the star's light in a way we can measure. Anglada-Escudé's team ran a dedicated campaign with a wonderful name, Pale Red Dot, watching Proxima Centauri night after night from a telescope in Chile, waiting to see if the star was being tugged by something unseen. It was. Read that again. The nearest star to us, the very next one over, has a potentially rocky, potentially temperate planet circling it. If humanity ever builds a probe to reach another star, this is almost certainly the first place we'd aim it. But, and there's always a but in honest astronomy, Proxima b faces a serious problem. Its star is a red dwarf, and red dwarfs are violent. They erupt with enormous flares of radiation that could strip an atmosphere away or sterilize a surface. And the planet is likely tidally locked, meaning one side faces its star forever in permanent day, while the other freezes in eternal night. It might be habitable. It might be a scorched, irradiated rock. We genuinely don't know yet. Quick question while we're here, drop it in the comments. If we could send a single probe to just one of these worlds, which would you pick? The Earth-like cousin, the seven-planet system, or the one right next door? I read these, and they shape what I cover next. And now we come to the discovery that tends to unsettle people the most, the one that pushed this whole field from, are there other Earths, to, is something breathing on one of them? The planet is called K218b. It's a sub-Neptune, bigger than Earth, around 8.5 times our mass, orbiting a red dwarf about 124 light-years away in the constellation Leo. On its own, that's not remarkable. What's remarkable is what the James Webb Space Telescope found in its air. In 2023, a team led by Niku Madhusudan at the University of Cambridge used Webb to read K218b's atmosphere, and they detected methane and carbon dioxide, consistent with a world that might have a vast liquid water ocean beneath a hydrogen-rich sky. They gave this kind of world a name, a Hycean planet from hydrogen and ocean. Picture a planet with no land at all, one endless global sea, wrapped in a thick hydrogen sky. If that idea is right, worlds like this could be some of the most promising places to look for life anywhere, because there are far more of these sub-Neptunes in the galaxy than there are planets exactly like Earth. That alone would be a huge deal. But it was a third, fainter hint that set the internet on fire. They saw a possible trace of a molecule called dimethyl sulfide, or DMS. And here on Earth, DMS is produced almost entirely by life, mostly by marine plankton in the oceans. Then, in April 2025, Madhusudan's team went further. Using a different Webb instrument, they reported signs of DMS and possibly a related molecule at what scientists call 3 sigma confidence. Now I have to be very careful and very honest here, because this is exactly where most videos lie to you. 3 sigma sounds strong, but in this field it is not a discovery. It means roughly a 3 in 1,000 chance the signal is a fluke, and to actually claim something, scientists demand 5 sigma, a level hundreds of times stricter. And almost immediately, other independent teams re-examined the same data and pushed back hard. A NASA-led group at the Jet Propulsion Laboratory, along with several other researchers, found that the evidence for DMS was not robust, that the signal might vanish under different, equally reasonable assumptions. Madhusudan himself, to his credit, has been cautious, saying plainly that this is not proof of life, and that unknown chemistry might explain it. So no, we have not found aliens. But stop and sit with what did happen. For the first time in human history, we pointed an instrument at another world, read its atmosphere, and had a serious, sober, scientific argument about whether we were looking at the exhaust of living things. That argument is real, and it is ongoing right now. As I record this, more Webb observations are being gathered and reanalyzed, and the honest scientific answer to, is there life on K218b, remains the same three words it should be. We don't know. But we're asking it with data now, not just imagination, and that is genuinely new. Let me pull you out of the data for a moment and put you somewhere. Imagine standing on the surface of one of these worlds, a rocky planet circling a red dwarf star. The first thing you'd notice is the light. It's wrong. It's dim and deep red, like standing outside at the very last moment of sunset that never ends. The star hangs huge and low and swollen in the sky, several times wider than our sun looks, but giving off a sullen, bloody glow you could almost look at directly. If the planet is tidally locked, that star never moves. It just sits there, fixed at the same spot on the horizon for eternity. There is no sunrise, no sunset, no day and night, just an endless red afternoon on one side of the world and an endless frozen darkness on the other. The air, if there is air, might be thick and heavy, pressing down on you. The ground could be volcanic, restless, still cooling from the planet's violent birth. And it would be quiet, no birds, no insects, none of the background hum of a living world, unless something down in those dim red oceans had learned the trick of being alive. And somewhere far above you, invisible in that crimson sky, a telescope built by a species you'll never meet is reading the chemistry of the very air in your lungs. That's not a fantasy. That is quite literally what our instruments are now capable of doing. Now step back, because this is where the stakes stop being academic and become something deeper. For thousands of years, the question, are we alone, belonged to philosophers and dreamers. It was unanswerable. Beautiful, but unanswerable. That is no longer true. We have crossed a threshold. We now have the technology to detect the chemical signatures of life in the atmospheres of planets trillions of miles away, and we are actively doing it. Think about what that means. If, somewhere in the next decade or two, one of these atmospheres shows an unmistakable combination of gases that simply cannot exist without life, and it survives every skeptical reanalysis, every independent team, every attempt to explain it away, then in a single moment, everything changes. We would know, for certain, that life is not a one-time miracle, that the universe makes it more than once. And here is the flip side, the quieter, colder thought. What if we keep looking at hundreds of these worlds, then thousands, and find nothing? No signatures, no breath, just dead air, over and over again. That silence would be its own kind of answer, and arguably a more frightening one. Either way, we are the first generation of humans able to actually ask the universe this question and get a real reply. Think about the people who came before us. Every human who ever lived, from the first person who looked up at the stars and wondered, all the way through Galileo and Newton and beyond, every single one of them died without knowing whether any of those points of light had worlds, let alone living ones. They could only guess. We don't have to guess anymore. We have the machines. We have the method. And the answer, whatever it turns out to be, is now something we can actually measure in our own lifetimes. That is a genuinely new thing under the sun. And now zoom all the way out. Kepler 452b, TRAPPIST-1, Proxima b, K218b, these are 4 worlds. 4. And here's the number that should reset your sense of scale entirely. Based on the data Kepler sent home, astronomers estimate that roughly 1 in 5 sun-like stars may host an Earth-sized planet in its habitable zone. 1 in 5. Our galaxy, the Milky Way, contains somewhere between 100 and 400 billion stars. Do the arithmetic, and you're left staring at potentially tens of billions of Earth-sized worlds in the temperate zone in our galaxy alone. Tens of billions. And the Milky Way is just one galaxy among an estimated 2 trillion in the observable universe. Everything we've found so far, every headline, every Earth 2.0, every possible whisper of life, has come from examining the tiniest sliver of the nearest stars. A few grains of sand from an endless beach. We have barely started looking, and we've already found worlds that look like home and air that made scientists argue about life. Imagine what's waiting in the part we haven't checked. And remember, every one of these discoveries came from just the last 15 years. Kepler wasn't even in space until 2009. Webb didn't open its eyes until the end of 2021. In the span of a single human childhood, we went from knowing of 0 planets around 0 other stars to cataloging thousands and reading their atmospheres. The pace isn't slowing down. It's accelerating. So what does all of this actually add up to? Here's what I want you to take away. We have not found Earth 2.0, not really, not a confirmed twin with oceans and life. Not yet. What we found is something in some ways more important. Proof that worlds like ours are common, that the ingredients are everywhere, and that we finally have the tools to check whether any of them are alive. A generation ago, another Earth was a line in a science fiction novel. Today, it's a research program with budgets, telescopes, and deadlines. The question has moved from if to when. And that shift, from dreaming to measuring, might be one of the most profound things our species has ever done. We stopped wondering, and we started looking. Somewhere out there tonight, one of these worlds is turning slowly under its own strange sun, its oceans catching that alien light, completely indifferent to the fact that a small blue planet has finally learned how to notice it. We may not have found our twin yet, but we now know, beyond any doubt, that the sky is full of candidates. And the universe, it turns out, is far more crowded than we ever dared to assume. If you want to be there when the next chapter drops, and it's coming faster than you'd think, subscribe and turn on notifications. Because Webb is still staring at K218b and worlds like it right now, gathering more data to settle that biosignature debate one way or the other. And behind it, a new wave is almost here. NASA's Nancy Grace Roman Space Telescope, the European Plato mission hunting Earth-like planets around sun-like stars, and further out, a future flagship designed to do the almost unthinkable, to directly image another Earth and scan its air for the signs of life. We are closer to answering humanity's oldest question than any people who have ever lived. Thank you so much for watching. Keep looking up, keep asking the big questions, and I'll see you in the next one.